Okay, so we're live now. Good evening, everyone.
Good evening, sir.
Good evening, sir.
Want to remind you all of the rules. We're going to keep our cameras off for privacy purposes. We're going to wear earphones so that we don't have a feedback loop going. And we're going to make sure that we wait our turn so we're not talking over each other. Right now, I can tell you, I can hear myself coming back from somebody's speakers. So let's turn that down and work on that. So let's see. We'll start with Rajay.
Yes, sir.
Read the numbers that you see on screen, please. All right, she doesn't seem to be ready. Let's go to Anna K. Anna K, read numbers you see on screen.
Sir, I can't see the screen.
Okay. Let's go
Sir, I
then
can see the
to.
screen.
All right, I'm not certain who that was. Go ahead. Who is that? Trishan, are you able to see it?
Yes, sir.
All right. Tell me what we have. Still waiting. All right. Talia, pick up, please.
Sir, 2608,
Plus.
98,
Plus. Yes. Plus.
369,
All right. So 9 and 8 will give us what?
25. Sir, no. Sir, because
9
I'm
and,
adding all of them.
17.
okay. So 9 and 8 will give us 17. And we need to wait our turn before responding. 17 and 8 would give us
25.
25. All right. So we have 25. We're going to write what? 5 and carry 2.
2.
So 2 and 9 would be
11.
and 11 and 6 would give us what?
6. 17.
We're going to write 7 and we're going to carry 1. 6 and 1 would give us
7.
7 and 3 would give us.
10.
So we're going to write 0 and carry.
1.
And 2 and 1 would give us.
3.
So our answer is. Not hearing you tell you what's the answer.
Sir, the answer is 375.
No, it's not 375. What's the answer?
3,075.
Make it nice and clear for me.
5.
Say that again. Not clear. Our answer is
3,700.
no, it's not 3,700.
75.
3,075. All right. Let's go. Shade.
Yes, sir.
Ready? How many even numbers are there between 11 and 19? So here we have listed the numbers 11, 12, 13, 14, 15, 16, 17, 18, 19. Because they say between, we can't use the upper number or the lower number. So we can't use 11 and we can't use 19. So we need to find even numbers. Now, what are even numbers, Shade?
Even are numbers that 2 can go into without leaving a remainder.
Okay. So tell me, what do they end with in the ones place?
0, 2, 4, 6, and 8.
Okay, very good. So tell me, 12 is even?
Yes, sir.
13,
No, sir.
14,
Yes, sir.
15,
No, sir.
16.
Yes, sir.
What about 17?
No, sir.
18?
Yes, sir.
All right, so let's see how many we have. 1, 2, 3, and
Four.
so my answer is equal to 4. If I'm asking Shay to answer, please let the rest of us give him a chance. All right.
Yes, sir.
All right. So gonna go back. So Rajay, call this number for me. Number on screen. You people have to respond. Rajay, you there?
So I can't see the screen.
Okay, well, you have to be able to see the screen to participate.
Okay, sir.
Anna K,
Yes, sir.
call the number on screen, please.
Three million. No, yes, sir. 3,000,000 9,465.
Not quite what we want. Let's go with finding the place value. 5, everybody, 5 is in the what place?
One.
And 6 would be in the what?
Tens.
4 would be in the what?
Hundreds.
9 would be in the what place?
Thousands.
And then 0 in the what? Tens of thousands.
Thousands.
And 3 would be in the what? 100,000. So, Anake, this number is 309,000 what?
460.
So, Anake, call this number again for me, please. Not hearing you. Go ahead. All right, everybody, call the number for me.
309,465.
All right, thanks. All right, so we go to Trishan. Trishan, show 7 in the hundredths place. We're going to show 7 in the hundredths place. Which one of these options, let's call this A, B, C, and D, which one shows 7 in the hundredths place?
A.
Okay, let's see. The number that is to the left of the decimal place will be the ones column. Then to the left of that we have what?
Tens.
To the left of that we have what? Hundreds. 1 place, 2 place, 3 places, hundreds. Let's go over now to the right of the decimal point. That column will be what? Anybody?
Fraction.
Yes, we know a fraction, but what specific fraction? It will be at 1/10. The other will be hundreds, thousands, and this will be what? 10,000. All right. So she said she selected A as the answer. Right? She said A. Is 7 here? Let's look. Is it in the hundredths place?
No, sir.
What place is it in?
The ones.
place.
So we know this one can't be right. So let's look at it. Trishan, go again. What?
C.
Which one?
C.
D, sir.
C.
C.
Okay. C.
Yes.
So let's look. 4 in the ones place, 0 in the tens place, 7 in the hundredths place. All right, so C is correct.
Yes, sir.
So you see, we have to pay special attention to the what? To the place
Place
value,
value.
both on the whole number side and the decimal side.
Yes, sir.
Charlie, this one is yours. Which elements are common to both set Q and set P?
Sir, 5 and 2.
So 5 and 2. So Q intersects P, and that set would be equal to 5 and 2.
2.
Okay. So set Q has 6, 3, 5, 2, and 8. And set P would have 5, 2, 1, 4, 7, and 9. If we were asked to list these, let's say Q union P, what would we list as the elements there? Anybody? Talia?
Sir? Sir, what
Well,
was the question?
Q union, the union of Q and P. What are the elements there?
The union of, sir, 6, 3,
Let's start with the lowest ones first.
Sir, 2.
1,
No, let's go 1.
1, 2.
Look. So we have used 1, 2,
3.
3,
4.
hold on, 4.
6.
5,
5.
What about 5? Yes, 5.
6.
We have 6,
7.
7,
8.
8,
9.
and 9.
Yes, sir.
Hold on. But we did not use 5 and 2 times. Why not?
Sir,
sir,
because
because they're
Go
they're
ahead,
members
Corey.
of both of the sets.
And so why didn't we list them 2 times since they are members of both sets?
Because you don't have to list them 2 times because they're already in both of the sets
All right, so we just write them once.
once.
All right, good. Let's go. TC, you're up.
Yes,
We have
sir.
12 point. What? Help me call this. 12 point
682.
is not 12.682.
No, sir.
Oh, okay. So 12.682, and we're going to round that to the nearest tenths. All right.
Yes, sir.
So help me now. Where are my whole numbers?
Sir, right, sir, right side to the point.
Yes. Over here.
Sir, that is the text.
Hold on. Let me see if I can get this. Okay. So here's my pointer. Everybody seeing it now?
Yes, sir. Yes, sir.
Okay. So where this is, what should I write here?
Sir, 1/10.
Okay, so 1/10. And then the column to the right of that is?
Sir, 100.
Hundredths. And then?
1,000.
1,000. What about the digits or columns that are to the left of the decimal point?
Sir,
Now let's give TC. Let's give TC the chance. TC 2. What column?
Sir, one's column, sir.
Okay, and 1?
Ten's column.
All right, great. So we have that locked. So let's
Yes,
go
sir.
now with rounding. What column am I rounding to?
Sir, 10's column, sir.
So find it and underline it. What do I need
Yes,
to
sir.
do now?
Sir, if the number is 5 or more, it is in
No,
our
which
rounding.
number? Which number? The 2 or the
No,
8?
sir, 8.
The number to the what?
Right.
Right. Okay. So if it is 5 or more, it's in our rounding up. And if it is
4 or
4
less, it is
or
in our rounding.
4 or less, it's in our rounding down group. All right. So 5 or more, we're going up. 4 or less, we're going down. So what do we
Yes.
do now? 8 is
Sir,
5 or more. So what do we do?
we add 1 to the digit to our left and put 0 for the rest.
Okay, so I'll keep my 1
Whole
2
number.
point and add 1 to the 6. This becomes 7. And we can put 0 for the
0
rest
for
if
the
we want to
rest.
hold those places. All right. Of course, we know that this could easily be rewritten as 12.7.
Yes, sir.
Okay. Because 12.7 and 12.700 are actually what?
The
Equivalent.
same thing.
All right. Let's look at 12.7 and 12.700. 12.7 is 12 with 7 tenths, and 12.7 is 1, 2, 3. This would have what? How many?
700, sir.
So let's see.
7,000.
Yeah, 7,000. All right. So if we say 0 cancels 0 and 0 cancels 0, we are going to be ending up with 12 and 7 tenths being equal to 12 and 7
10.
tenths. So they are both what? Equivalent. All right. After we've done our canceling, we find out that they're equivalent. When I said 0 cancels 0 and 0 cancels 0, what does that mean?
So you use by power of 10.
I'm dividing by a power of 10. Both the numerator and the denominator are being divided by powers of 10. So if I divide by 1, I'm dividing by 10. If I divide by 2, I'm dividing by 100. Somebody's speaker is way too loud. All right. Okay, so we go to, let's go to Corey.
Yes, sir.
This is 714, and we're going to divide that by a decimal. What's the decimal we're dividing by?
0.7.
What do I need to do?
Sir, since it's a decimal, you can't divide the whole number, right? So you'd have to do you would have to multiply the 0.7 by 100.
By 100 to make it
So
whole?
10.
Okay, 10. And when I do that, it will now become what?
It would now become 7.
Okay, let's see if I can write 7. And if I do that to the divisor, I also need to do it to the
Dividend.
So this 714 will now become what?
7,140.
7,140.
Who's going to tell me that?
All right, help me set this out. What goes where?
Put the 7 outside.
7 goes outside.
Put the 7,140 inside.
Oh, let's, every
Dog was swim
dog
Dog must swim back.
must swim back. All right, and
Estimate, divide,
estimate,
multiply,
divide, multiply.
subtract, bring down.
All right, good. So here we go. 7 into 7.
1,
1 times 7.
7.
And we're going to do what?
Take away, leave 0.
And we're going to do what?
Bring down.
Then we say 7 into 1.
0.
Okay. 0 times 7 would give us what?
0.
And then we're going to do what?
Subtract equal 1.
And then we do what?
Bring down the 4.
And 7 into 14.
2.
And 2 times 7.
14. Take away.
We have
0.
what? And we bring.
Down the 0.
Okay. And 7 into 0.
0, 0 technically.
All right. Yes. And then we have 0. So our
So I would
answer.
have just brought down both of the numbers that would make 14
All right.
to
Cool.
make it shorter.
All right. So look at this now. So if we needed to check to see if our answer is right, what would we need to do?
Multiply the multiply 1020 times 7.
What's the 1020 called again?
The quotient.
Okay. And the 7 would be the what?
Divisor.
Okay. All right. Just checking to make sure that we have all the terms correct. So
Dividend
1020, and we're going to multiply by 7. And when we multiply by 7, what we're hoping to get back,
would be 7,140.
which is called a what?
The dividend.
Okay. 7 times 0?
0.
I
Okay.
cannot see the screen.
7 twos?
14. Carry the 1. 7 times 0. 0. The 1.
Bring down the 1.
7. 7.
No,
times
7
1.
times 1. Yeah. All right. All right. That looks good. Just one other thing I would want to remind you guys of, that we could have had 7, 1, 4 all over 0.7. And we could show that we need to move this one place to make it a whole number. And if we have the unstated decimal behind the 4, then I would add a what? Placeholder and move that one place as well. Then I would end up with 7140 all over 7, which is the same thing that we have here. Okay?
Yes, sir. The whole time as I was doing that problem, I had a fudge stick in my mouth.
Okay, let's see. Oh, good. Trishan, are you there?
Good.
Here we have
Sir, I
5%. Okay, if you can't see the screen, maybe you need to just watch on YouTube. Yeah, because you really need to see the screen in order to participate.
Yes, sir. I'm seeing the screen as well.
Excuse me, sir. Then she press Mr. Ludford.
Okay. You
Then
hearing
she
that?
press 01.
Are you hearing that, Anake?
Yes, sir.
Are you seeing the screen now? Shady is saying press my name and you should see the screen. Is that working for you?
No, sir.
All right, we have to sort that out tomorrow, but
Sir, that's what I did.
okay. All right, so Sally, let's go with this one.
Sir?
What is 5% written as a decimal?
Sir,
What will I need to do?
Sir, as a decimal, it is 0.05.
Let's see. What would I need to do with this? 5% can be written as a fraction being 5 over
100.
100. What does this mean now? 5 divided by 100 means? What's the short way of doing this?
Sir,
I have two
Okay.
zeros here. What does, what could we do?
sir, you got
100.
No, I can move this decimal point. How many times?
2 times.
2.
2 times. Let's add some zeros here to continue. So I can move it 2 times. 1, 2. So my answer would be 0.05. Clear? Let's look at this in another way.
Yes.
5, 100. The denominator becomes the divisor, and the numerator becomes the dividend. Okay. So let's go with this. Can 100 go into 5? No. 0, add a decimal point, add 0 to continue. Can't work. Can 100 go into 50?
No, sir.
Can't work. Add a 0 to continue. Can 100 go into 500? Yes, that can
Yes,
work.
sir.
5 times 100, 500. That will leave us with 0. So when we do it this short way, we can see how it will be done long. Okay? So Tally, you're right. Please tell me what the answer should be.
So the answer should be 0.05.
So 5% written as a decimal is,
0.05.
thank you very much. TC,
Yes, sir.
go ahead with this one. Read it for me, please.
3.654 times 100.
And what would that be?
Sir. Could you set it up there?
Well, if we're working it the short way, we don't need to set it out. Because if we're multiplying, we're going to move our decimal point to the right. And we have 2 zeros, so we could move it, 2 times. True?
Yes, sir. The answer will be 365.4, sir.
All right. Let's see if we had set this out as 3.654, and we're going to multiply that by 100. How many decimal places we have here?
Sir.
How many?
2, sir.
3.654. How many decimal places would be there?
Sir, 3.
3 decimal places. Our answer needs to have 3 decimal places. Let's go. Well, we're going to go the really long way. 0 times 0, 0. 0 times 5, 0 times 6, 0. 0 times 3, 0. So we finish with this one. Moving on to this one. So we need to start here. Put a placeholder. 0 times 0, 0 times 4, 0. 0 times 5, 0. 0 times 6, 0. 0 times 3, 0. What do we know about 0? Any number times 0 is?
Is 0.
Okay, I'm going to start with the 1. So my answer should start there. So I put 2 placeholders. 1 times 4 will give me what?
4.
4. 1 times 5 will give me 5. 1 times 6 will give me 6. 1 times 3 will give me 3. Let's add all of these together. 0, 0, 4, 5,
6
6,
and
3.
3.
I know I need placeholders now, 3 decimal places. So I'll go in 1 place, 2 place, 3 places. So I now have what? 365.4. Okay. So here, shortcut, we simply move the decimal point 1, 2 places because we have 2 zeros. Okay. When you go to high school, they're going to tell you that you don't move the decimal point. You actually move the what? Digits. Okay. All right.
So one thing I don't understand, how can you move the digits and without moving the
Okay.
decimal?
So here we
Always
go.
set it out.
Same way, same way. It's just that instead of saying we're moving the decimal point to the left, we're going to be moving the digits to the right. Sorry, we move decimal point to the left, the right when multiplying, but move the digits to the left when multiplying. So you get the same result. If this is 3.6 and I need to move them 2 places over, I'm going to take these 2, move 1, then move 2. And what will we have left? 3. I move 6 over, then I move 5 over. I have the decimal point, and then I have 4. So it's the same thing, okay? But just for now, you want to show the movement of the decimal point. Just for now. High school, move the digits. Because they say in high school that the decimal point is like the what? Sun. The sun does not move, but the planets move around it, okay?
Yes, sir.
All right, cool. So let me say that again. For now, we're saying that the decimal point moves to the right when we are multiplying, right? And if we are talking about the digits will be moving left if we are multiplying, okay? If we are dividing, we would say that the decimal point moves to the left while the digits move to the right.
Right.
Okay. All right. Who's up next? TC? No, she. Is it TC? Shade. Please do this one for me. What is 3/8 expressed as a decimal? What does this mean?
Multiply, sir.
No, we're not multiplying. Think about it some more.
Sir, can I answer?
Okay, throw my lifeline.
Say, you have to find the equivalent fraction with a power of 10.
That's an interesting way of looking at it. You want to know what I would do?
Yes.
Yes.
I would say 3/8. Set it out as 8 into
Divide.
3.
Yes, sir, and
8 into 3 can't work. Decimal point. Add 0. 8 into 30.
3 times.
3 times. Hold on, let me fix up my 3 properly. Oh, gone. Hold. Yes. Let me swap colors. So 3 times 3/8 will give me what?
24.
24. Take this away. I'll have 6 left. Add a 0 to continue. And 8 into 60.
goes 7 times.
Okay, so 7/8 would give me what?
48.
No, sir.
Sir,
Come on, guys.
50,
50 what?
56.
56. Okay. I subtract and I have what left?
4.
Add a 0 to continue. 8 into 40 now would go.
5
Okay, hold on. This 5 not right properly. Let's write it properly. So 5/8 would give you 40, and that would bring it to an end, right? So
Yes.
shade as a decimal, what's the answer?
0.375.
Okay, hold on a minute, guys. Give me a second. Okay, ready again. What is the reciprocal of 2¼
Yes, and that's mine.
No, that would be Rajay.
Oh,
So it will be 4/9.
4/9.
Yes,
Tell me
sir.
what I need to do first.
So you
2¼
so you multiply the whole number by the denominator, and then you add the numerator.
What
Sir,
am I doing? What you call that process?
So changing it to an improper fraction.
Okay. All right, so we're changing the what?
Numbers.
Mixed number to an improper fraction.
So this will give me what?
I'm done.
9.
9/4.
4.
So what's the reciprocal of 9/4 or 9/4?
4/9.
4
9.
9s.
Yes, sir.
All right, let me fix up my 4. How do I know that this is the reciprocal?
So because the denominator was 4 and the numerator was 9.
Not quite. When I multiply the number by its reciprocal, what should I get as the answer?
Whole.
1. So 4 into itself, 1 time, 4 into 4, 1 time, 9 into 9, 1, 9 into 9, 1. Numerator by numerator, 1 times 1 will give me,
1.
and 1 times 1 will give me
1.
1/1, which is the same as 1.
Whole.
1 whole. So I know that the answer here, answer equals, what's the answer?
4/9.
4.
9.
I have to work on these 4 tonight. Let me see if I can find our place. All right, so 4 9s. Okay, so Corey, next one is yours. Arrange the following in descending order. Corey, what does descending order mean again?
Sir, from highest to lowest.
Okay, so from largest to smallest. Okay. So what would I need to do to make this comparison? Anybody wants to help out?
Sir, the screen
Yes, sir.
froze, and I just heard that you're asking if anybody would help me.
Okay, so what do I need? What's the next step?
Sir, you try and find the LCM of the following.
Okay. So 2, 8, 16, and 4. What's the LCM there?
16.
16. Okay, so let's use 16. So 2 into the 16 will go how many times?
2 into 16 goes 8 times.
Use that factor
And
of
you
8 and multiply
the 8 times the numerator.
the numerator. So 8 ones would give us?
8.
All right, so we're using 16. 8 into 16 would go,
2. 2 times
use,
7 would be
will give
equal
us what?
14.
14. 16. 16 into 16.
1.
So 1 times the
1
13
times
will give us what?
13 will give
13.
13. And using 16.
And
4 into
46 will go
16.
4 times.
4
And
times
4 times 3.
12.
12.
So now that we have the common denominator of 16, we can focus on the what? Numerator to arrange them. Let's review something here. A half, what is the equivalent fraction for the half? Not hearing your query.
Okay, sir, it would be 2 over 4.
That's not what's there.
8
Oh.
over
Oh, not on the under.
6.
Okay, so
Yeah.
it would be 8 over 16.
Or 8/16. What 7/8? What's the equivalent fraction that they gave here for 7/8?
14 over 16.
The equivalent fraction for 13 over 16?
13 over 16.
Okay. The equivalent fraction for 3/4?
12 over 16.
All right, so let's arrange them now. And we are looking for the largest to the smallest. So which one is the largest?
Sir, the 14 over 16.
What fraction represents that?
7/8.
So 7/8 comes first. Then what? So this one has been used.
Sir, yes, sir, and it would be 13 over 16.
Okay, so 13 over 16. Then
Be 3/4.
3/4. And finally,
A half.
a half. So remember that we have to give them back based on the what? Based on the original fractions that were given. So we have to, even though we find them here, find the equivalent fractions, we can't use these. We need to show how the original fractions, the stated fractions, should be arranged based on the order that they have prescribed. Okay,
No,
Sally?
sir,
Yes, sir.
How many sixths, how many 1/6 are in 36? What's this asking us to do?
So it is asking you to
What operation?
third division.
Exactly. So what am I asked to divide?
So 1/6 and 36. So it should be 36 divided by 6.
36 divided by 1/6. We're trying to find how many times we can take 1/6 out of 36. Understood?
Yes.
All right. What do we need to remember here? Not hearing you clearly. Go again.
KCF.
What KCF means?
Keep, change, and flip.
So we keep, we change, and we flip. So we keep the dividend, 36 over 1. Change the sign to what?
Multiplication.
Why multiplication?
So because it is a division problem.
And all fractional division problems are multiplication problems in disguise. So when we say flip, what are we finding here?
So you're going to flip. You're going to flip.
Yeah, I want to know what we call this now. 6 over 1. What's that? An R word. Is that an R word? The reciprocal of the divisor. All right, so we are now going to multiply. Can we reduce anything?
No, sir.
So with it's simply what? Numerator by numerator and denominator by denominator. 6 would give us what? 36. We'll carry what? 3. 6 threes would be 18. 18 and 3 would be what?
21.
21. Let's set this out for persons who are not able to visualize that. 6 is 36. We're going to write 6 and we're going to carry 3. 6 threes would be 18. 18 and 3, 21. So our answer would be what? 6 would be how many 6s are in 36? 216. Right?
Yes, sir.
Let's see. TC, your question.
Yes, sir. Sir, find the LCM.
Okay. What do I do with this?
Sir?
What do I do with this number?
Sir, we change the mixed number into an improper fraction.
And okay, so this becomes 2/3 plus 3/6 plus I don't know what this should be. You have to help me.
9
Okay, 9 over
4.
4, and that was what? 4 2s 8 and 1 9. What's the LCM of
12.
12? Okay, so if we're going to use 12, let me swap colors here. I'm going to use 12 to make all of these common.
Yes.
3 into 12 would go,
4 times.
and 4 times the 2 would give us
8, sir.
6 into 12 would go,
2 times.
and 2 times the 3 would give us
6, sir.
okay, and 4 into 12 would go,
3 times, sir.
and 3 times the 9 would give us
27, sir.
27. And what operation are we doing again?
Addition.
So let's add these. 8 and 6 would give us what?
14, sir.
Okay, so we have 27 and we're going to put on 14. 4 and 7 would give us what?
11, sir.
Right, 1 and carry 1. And what would this be? 2 and 1 and 1 more would give us what?
4, sir.
So this would be equal to what? 40
1.
over 12.
12.
Can we do anything with this?
Yes, sir.
What could we do?
Sir, can
So
you
we change it into a mixed fraction.
Okay, so 12 can go into 41 how many times?
4 times. 3 times.
3 times. 3 12s would be 36.
Yes, sir.
Remainder?
5?
5 over.
12.
All right. Let's see who's next. Shade, which is the only prime number that is even?
2, sir.
Okay, so 2. 2 is the only prime number that's even. The first couple of prime numbers would be 2, 3,
7.
what else? 5,
7.
7, 11,
13.
13,
17.
17.
21.
Somebody just said 21. 21 is not prime because
No,
what?
sir.
If I add these two, I get
3 into
3.
7
All right.
and
So,
7.
all right.
Yes, sir.
So we're going back now to Rajay. Rajay,
Yes, sir.
4/5 minus 3/8. Help me to solve that. What do I need to do?
So you have to find the LCM.
In this case, what's the LCM?
40.
5 into 40.
5 into 40 goes 8 times.
And 8 times the 4.
32.
32 minus something over 40. 8 into 40.
Goes 5 times.
And 5 times 3 will give us?
15.
All right. So what's the answer here? 15 from 32 would give us how many?
17 over 40.
Okay. 17 over 40.
40.
Let's yeah, some people are not going to see that. So 32 and we take out 15. We can't take 5 from 2.
So you are
And what do I say?
5.
5 from 12 would leave us with 7. And 1 from 2 would leave us with 1. So
One.
this is how we right. So this is how we got the 17 that was there. So our answer here
Will be 17 over 40.
17 over 4.
okay, excellent. Corey, this long one is yours.
Why do you always pick me last and I get the long ones?
All right, so read with me.
54 eggs were to be shared equally among 9 students, but 18 of them broke before they were shared. Show the mathematical calculation that will give the amount each student received.
Which one are these?
Sir, A, B, C, D.
A, B, C, D.
Sir, I would say C.
C. Do we have anyone who is picking a different answer from C?
No.
She said
Yes,
she
sir.
said C.
Yes, sir.
Which
B,
one?
sir.
Yes, sir. B. B,
B?
sir.
Yes, sir. B.
Yes, sir. B.
Shared. Shared.
All right. Let's look at this.
Sir, can I table my answer because I'm just realizing what they're saying?
Okay, go ahead.
Shared. B, divide.
Yes, sir, B.
So what's the answer that we think they should have?
B. B, sir.
And I don't think so.
Sir, shared and divide, sir.
But look at what happens. There are 54 eggs and they were to be shared equally among the 9. But 18 of them broke before they were shared. So the sharing does not happen yet. The sharing happens after some of them were broken. How many of them were broken? 18. So when we take out the 18, then whatever is left, we're going to share that among what? Among the 9 students. Yeah, man, the only letter in the alphabet. Oh.
Them. Oh, them.
I'm writing
Hey.
So you see how we have to really read deeply into the question?
Yes, sir.
Yes, sir.
If we don't read deeply
Sir,
into the
so the
question.
alphabet. Sir, so the alphabet goes O, 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 O,
Yes,
O.
yes. All right. So here it is that we have to pay attention to it. We had 54 eggs and they were to be shared. It didn't happen because 18 of them were broken. And then afterwards, now, whatever was left, we shared between the 9 students. Okay?
Yes, sir. So what is the answer, sir? C?
Yes, the answer is C.
Yeah,
I'm so sorry that you got it wrong.
sir, I'm going to take my correct answer.
Okay.
I don't care.
Let's go to Talia. Talia, what is this number in exponential form?
I wish I'd got that one.
I'm writing it down and I'm going to work it out. Say 7,000.
Let me put this over here in the meantime. 10 to the 0 power is 1. 10 to the first power is 10. 10 to the second power is 100. 10 to the third power or 10 cubed is 1,000. 10 to the fourth power is 10,000. 10 to the fifth power is 100,000. 10 to the sixth power is 1 million. So what does this 7 represent?
Says it represents 1,000.
7,000. This represents 500. We have no what? No tens. And 6 times 1. Okay, so 7,000 rather is really 7 times 1,000. 500 is really 5 times 100. 0 times 10, let's leave that there. And we have 6 times 1. Let's look at this. Using these, how can we convert? This would be 7 multiplied by 10 to the what?
Third power.
10 to the third power. Plus, help me now. 5 times
To the
Second power.
10 squared. All right. Times 10 squared. Plus 0 times 10 to the first power. Hold on. Let's fix up this 10. 10 to the first power plus 6 times
10 to the 0 power.
10 to the 0 power. Are we clear? Are we clear on that, Tally?
yes, sir.
So an easy way of doing it is to write our number in expanded form, and then we slowly change it over until we get it to the exponential form that they're asking for.
Yes, sir.
Almost done. TC, complete the following with one of these rules. We have 2, 4, 6, 8, 10, 12. Which one of these rules, A, B, C, or D, will help me to find the number that comes here?
Sir, n plus 2, sir.
Okay, remember whenever we're looking at a sequence, we need to remember that there's a pattern or a rule. In this case, you're saying that the rule is what? Some number plus 2. So here, let's see if this is right. If I have 2 as the number, if I add 2 to it, what should I get?
4, sir.
If I have 4 and I add 2 to it, what should I get?
6.
If I have 8 and I add 2 to it, what should I get?
8.
If I have
12.
10, if I have 10 and I add 2, okay. So if I have 12 and I add 2 more, what should it be?
14.
So it appears that the rule is what? Some number, and we're adding 2 to it each time.
Yes, sir.
Okay, only 2 left to go. This one is for Shade. Shade. Anne has 15 mangoes and Pam has 10. What is the ratio of Pam's mangoes to Anne's. And we need to remember that we use the terms as they are given. So this is Pam. Pam has 10. Anne has 15. Let's give Shade some time.
Comment, sir. 2/3, sir.
Let's see. So you're saying this one is it?
Yes.
All right, that's what you've chosen. Anybody else has something different?
Yes, sir. Sir, B, sir.
B, sir.
Okay. Some people said it could be this one. Let's see. They ask us for Pam's mangoes to Anne. So Pam to Anne. Let's work with these now. So how many? What's Pam's share? What the number of mangoes Pam has rather?
10.
10.
10. 2?
15.
15. To Anne having 15 because it says Pam to Anne. Remember, they gave it as Anne first and Pam. They didn't ask us for that afterwards. They said Pam to Anne. So it's Pam to Anne. Okay. Now we're going to change this ratio to a fraction, and that will be written as 10 as the numerator and 15 as the denominator. What is the highest common factor?
There is A.
5.
What's the highest common factor? 5. So 5 could go into 10. How many times?
2 times.
2 times. And 5 can go into 15.
3 times.
So we end up with a fraction 2 over 3. So we need to change this fraction into a ratio, and we say this should be equal to 2 to 3. So of the 2 here selected, which one is actually correct?
A.
Alright, so A is actually correct and B is wrong.
Sir, just simply put the 15 to the 10 and then you reduce them
Okay.
as a fraction.
Everybody's favorite.
Roman numerals, sir.
Ready?
Your favorite to
What?
torture us.
What do we need to say? Medical Xavier. M for
1,000. 1,000.
D for
100.
500.
C for
100.
100.
L for
50.
50.
X for
10.
and V for
5. 1.
I for okay. Let's break this. M. M
1,000.
1,000. CM
400.
400.
900.
Oh, okay, 900. XL,
Yes.
M.
yes. XL,
40.
40.
okay, 40. And VI
7. No, 6.
6.
6.
So this is 1,000 plus 900
900
plus 40
and 46.
plus 6. Answer?
1,946.
1,946.
If this was a question that asked you to state, they saw this on the side of a clock, maybe the clock in Maypen, and they said the clock was built in this year. In what year was the clock built? How would you answer this?
1946.
Excellent. The clock was built in 1946. That brings us to the end of our class meeting for tonight. Thank you guys for joining. and I hope to see you all in the next episode. See you guys then.
Yes, sir.
Bye, sir.
Bye.